Now, as we look into our permutations, it's actually quite cumbersome to write long multiplication expressions like these. In math, we are given a way to shortcut or to shorthandly write this long mathematical expression. So, the product of 4 times 3 times 2 times 1 can simply be written as 4 with an exclamation point. And this is read as 4 factorial. So, definition is the factorial n factorial is defined for a natural number n as n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 times 3 times until times 3 times 2 times 1. Take note that this works if our n is a natural number, meaning it's from 1, 2, 3 onwards. Now, familiar with this definition? As you might remember, this is actually also the same definition as our permutation of n objects taken n. It has the same definition. So we can say that the permutation of n objects taken n at a time is also equal rather to n factorial, which would be equal to this expression here. So if we are going to go back to our previous examples, we can rewrite this as 6p6 is actually equal to 6 factorial, which will still be equal to 720. And the 7 students, 7 permutation of 7 taken 7, or sometimes more colloquially read as 7p7, can be written as 7 factorial, which would be equal to 5040. Most calculators have this notation, usually written as or seen as in the buttons or shift buttons as n factorial. So the calculator can immediately calculate the factorial notation of a given natural number. Let's work more with factorials. Take a look at this question. Is it possible to write 4 factorial as a product of 4 and a factorial? How about 10 factorial as a product of 10 and a factorial? Do you think these are possible? Pause the video and think of it. Now, 4 factorial, as we know, is equal to 4 times 3 times 2 times 1. So this is saying that we should write, my factorial is not that obvious. There you go. It should be like this. So, this is saying that I can write 4 factorial as 4 times a factorial notation. What I have, if I'm going to separate 4, is 3 times 2 times 1. And based on the definition of factorial, this is actually 3 factorial. So I can say that 4 factorial is also equal to 4 times 3 factorial. And that is the similar case if we're going to use it with 10. Sorry, there you go. So, if we're going to have 10 factorial as a product of 10 and a factorial, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we're going to separate 10, we're going to be actually left with the expression I just boxed, which is 9 factorial. So we can have 10 factorial as 10 times 9 factorial. So this is an important property or an important thing when we work with factorials, as most of our definitions with our other cases of permutation and other counting techniques will now be written in factorial. And remember, where the factorial is a shorthand of what we follow as the definition of permutation, which was defined through the fundamental principle of counting. One thing as well for factorials is the fact that it is defined that 0 factorial equals 1. Now, this is something that is defined so that defined so that we would have other definitions, theorems could work. So this is something that we cannot prove. This is really something that mathematicians said that we have to use this so that other counting techniques will work. So that the factorial notation will work, we define 0 factorial as 1. So these are the different things that we can use to shorthand a very long multiplication expression for our permutation through the factorial notation.